1 second. Oh, well, I think most people know each other, but probably in 2 separate groups. So hopefully throughout the day we'll be able to join in and learn about each other. So let me give a little bit of an introduction to Veena. Some of you already probably talked with her a little bit while you guys were talking over breakfast, but let me give a very short bio. So it'll be a little short and sweet. All right, so Veena received her PhD in Operations Research from Northwestern University and holds Bachelor's of Technology in Engineering from the IIT in Kanpur? Oh, yes. Oh, New Delhi, sorry, in New Delhi. She currently leads the Next Generation Solutions, Services, and System Reliability work in the Network Performance and Reliability Department at Bell Labs, also Lucent. Her technical interests include architecture, systems, network dependability analysis, software reliability, engineering, and telecom data analytics. She has published over 35 papers in referee conferences and journals. Veena is a senior member of IEEE, a recipient of Bell Labs President's Award for Outstanding Innovation and Technical Excellence. So please help me welcome Veena for our first keynote speaker.
Thank you, Brandy, and welcome everybody. I'm glad everybody's here. So, and feel free to, even when I'm talking, I need to get breakfast and coffee because most people just came in. So let's see. I don't usually use a Mac, that's why you'll see me fumbling around.
Well, the slides may be open.
Okay, so I'm looking for the Bell Labs.
Big interest.
It's maybe it's already open. So I'm trying to get
Which one is it?
the Bell Labs, the third one. Yeah. And then to get it to full screen.
It's full screen.
It is full screen,
Yep.
and I just hit return. Yeah. Okay. Before I get started with sort of the technical talk, I'm just going to tell you a little bit about Bell Labs, which is the R&D part of Alcatel-Lucent. So what is Bell Labs? Bell Labs has a big legacy. A lot of things were invented there, are still being invented there. It's the people, and there's a special culture of research and innovation, and there's also a lot of potential for new work. I'm just going to talk a few things about the legacy. A lot of things were done there in various areas, like understanding the universe. The transistor was invented there. I don't need to say, what the impact of the transistor has been. Also in the area of sustainability, a lot of work was done. Then connecting the world. The first interactive satellite was invented there, and that allowed communications across all parts of the world. And last but not least, amongst the other big things, in the area of managing information, Unix was invented there, and C. And those of you, there are many people here in data science. Those of you who use R, R is actually the predecessor for R was S, which was created at Bell Labs. In fact, when I joined in 1984, when many of you were not born, probably, we used to have S on all the mainframe machines, and that was the tool to use. You know, so you just kind of learned it. That's how you learned it. A little sort of a summary of different things that are happening in various areas, starting, you know, right from the 20s. The focus, though, is communications, but there were inventions made in materials, and then solid-state materials, microwave, semiconductors, cellular telephony, and currently, you know, the big challenges are cloud, elasticity, software-defined networks. So we're working on those kinds of things. And just to end, you know, typically a lot of technical challenges occur from some fundamental human desires, where people want health and peace and prosperity. And the way networks are evolving now, we're going, you know, the technology will evolve to meet those challenges and desires. All right, so that was a quick summary of, you know, where I work. So today what I'm going to do is really, the talk is about, I mean, I want to focus on storytelling with data visualization, because most people here are working with machine learning, data science. So I'll do a quick intro to data visualization principles and techniques, and then talk about storytelling. Sorry, full screen? What should I have? Press that? This one that's on top, but I want to get it full screen. Okay. So, you know, what are the goals of data visualization? You can think of it as four sort of primary ways. You want to record information, analyze data to support reasoning, reveal patterns, and communicate ideas to others. And I'll start out with some examples, some old examples. Here's a classic series of photographs where visualization is used to record information. Is anybody familiar with this? So this was done in 1878. What people wanted to know was if the forelegs of a horse, when it's galloping, are they ever all off the ground at the same time? And so think now, this is 1878. What this person did was he set up a bunch of cameras along the track, and they were and he set up some string, so when the horse went over it, it tripped and it triggered the camera, and he created all these photographs. And as you can see from here, that they were able to establish that the forelegs are above the ground, right? And the thing they also discovered was it was when the legs were together, you know, facing towards each other, like you see in this second photograph. And earlier they had thought it might be in a different position too. So this, I thought it was a pretty cool way to use visualization, and way back then. Another place where this is used is to reveal patterns, and this was in 1854, where at that time they didn't know that cholera spreads is a waterborne disease. And what here they were able to identify, they plotted on a street map the location of the water pumps and where the deaths were occurring. And based on this visualization, they were able to say that the deaths were connected to all the people who were using the same water pump. Those were the people all the people who had died were using the same water pump. So it gave them some connection, so the visualization helped with that to solve the problem, basically reveal a pattern. For analysis, this is a pictograph. You might call it an infograph nowadays. And here they were just looking at the trend of home and factory cleaving in England over the years. So they plotted the data in 10-year intervals. In the top row, you see the black figures represent all home cleaving, and the orange figures represent machine. And then as you go down, you see that by 1880, there's hardly any home weaving. It's all machine. So it's a good way to another form of analysis. This underground map. So this is used for communicating information. Again, here what you see is that this is not the first map that was created of the underground, but this is something that it evolved to at this time. And if you look at one now, it might be even slightly different. But it's stylized, and they show only certain things. Because if you're underground, taking the subway, you don't need to know the exact curvature of the roads and stuff. You need to know the general direction. The other thing I read about when they create the New York subway maps is you do need to know when you come up from the subway station where you are, like the cross streets. So it's different kinds of information that you need depending on the purpose. So visualization is good for communication. All right, so just a few kind of principles. I didn't ask, so in terms of time, you'll tell me if I'm running behind.
Yeah.
Okay.
45 minutes to an hour.
Okay. Yeah. So I'm going to mention a few principles and how to use color. If you're interested in data visualization, Edward Tufte is a big name. I mean, he has some nice books out. And it's good to look at his books. They're visually very appealing. I'll talk about some of the principles he talks about, like avoiding chart junk, maximizing the data ink ratio, and so the idea is that this data ink ratio is that your graphic, most of it should be about representing data, and you can have a little bit of extraneous stuff for embellishments, but try to maximize the amount of information that's there on your graph when you use some ink. So here it's very minimalist. Some of the axes, like the y-axis line, is not there. There's just, it's a very clean kind of graph. As opposed to here, we have a lot of chart junk. You have a lot of information here. Let me not put it, not information, but you have a lot of visual material here. What do you think is extraneous here?
Grid lines. The grid lines.
Yep. The background? Yeah. It's not very useful, right? So this looks better. So there are grid lines here. They're a little bit subtle, and we don't have the vertical grid lines. There's no need to show them for a bar chart, vertical grid lines, because the bar chart is there. So the idea is to avoid chart junk. The other thing is the integrity principles. Have good labeling. Don't distort the scales. And the graphic should be directly proportional to the numerical value. what's called a lie factor. I mean, you can lie with graphics, so avoid that. And show the data variation, not the design variation. So a couple of examples. Here's a graph where there's a lot of scale distortion. What you see is that they don't start at 0, so small variations seem very large. Look at the bottom, it's 49,000, but it's just a small. And the one above that looks like this very big variation. So one thing here would be to start at 0. That usually helps. The usual principle is to start your scale at 0. Another area to focus on is like have some alignment so it's clean. Usually if you're drawing these horizontal bar charts, try to sort them by value unless it doesn't make sense. So like this second chart is a lot easier to read, looks nicer. Okay, don't need to actually go through these, but you know, you have different types of data in terms of nominal, ordinal, which is ordered, and then quantitative data, numerical data. The nominal is the categoric data, like months of the year, days of the week, states. So when you're using color, there's some general principles where gray is, if you're using different shades of gray, it's usually perceived as ordered. So that's a good scale to use for ordered. It's not so good for quantitative values because you can't tell what the value is just by looking at the shade. And hue is normally perceived as unordered, so it's good for numerical data, the colors. Some authors, they suggest these sort of standard colors. Don't use very exotic colors, just standard basic colors. One thing to keep in mind is that when you use colors for categorical data, like is done here, which is good, they're showing different cities in different colors. Once you use about more than 8 colors, things get out of hand. 8, it seems like a good upper limit. Otherwise, you have to keep looking at the legend. And then if you have a lot of colors, the colors tend to be similar. So 8 to 10 is a good number. So just to summarize, hue is good for categorical data. Saturation is good for ordered data. And then luminance is good for ordered and quantitative data. If you're not sure how to use color, I would say stick to black and white. Because a bad color graphic, a good black and white graphic is always better than a poor color graphic. And it's not that easy to use color. When you start creating colored visuals, you'll see you can spend a lot of time on it. So when to use what type? Line graphs are sort of the common ones that simplest things you start out with. But in a line graph, you want the x-axis to be a quantitative variable. And what's good with the line graph is you're connecting the points. So it shows the difference between contiguous variables. That's important. You can only connect things when they're contiguous. If you have missing values, then you shouldn't connect the points because it gives us, it misrepresents the information. Bar graph is good for comparing relative point values, and scatter plots give an overall impression of the relationship between two variables. Okay, I'm going to move off this. Most people know how to make a graph. I'm sure everybody here has used the iris data in some form or the other. So here's what's called a four-fold plot with the iris data. And so what I'm showing here is, so I have 4 variables. One of them is categoric. That's the species of the iris. And there are 3. That's why you see 3 colors here. And then I've got the 4 variables, the 2 lengths, the 2 widths. So this, with just one plot, with one R command, I can make this plot. I plot every variable against every other variable, and I use color for the species. So this is a good way to use color. This is also called a draftsman display because in a way it shows 2D projections of 4D data. You've all seen heat maps. Those are also good. I mean, this is a heat map of different players and various indicators of their performance. Again, heat maps give a good overview, but then if you want to know something specific, then you've got to do some other kind of plot. You want to zoom in on something. Another good technique is parallel coordinate plots. Here, what you're doing is, so you have a few variables. What you do is you put them all on the same scale. In this case, it's different food products like dairy and egg products, and each column shows different vitamins or other ingredients that they have, and you just connect the lines. And what this lets you see is which products are similar in certain things and which products differ widely with certain things. Like if you look at this column that says vitamin C, most of the products are very close. They all are at the bottom. That means they hardly have any vitamin C. So that's a quick indicator. There's some nice tools that let you, like I use Ggobi, that lets you select a few interactively and then focus in on those. So that's how one would use one of these plots. And mosaic plots are very good when you've got two categoric variables. So here's a simple mosaic plot of hair color and eye color. It's showing the relationship. I mean, what people with say black hair and brown eyes, how many people. So the area of a particular region, that tells you the quantity. So again, it gives you the idea. And the color just shows sort of also. So we're using area and color here, but mainly area. You could do without color here if you wanted. You could just use area. Another type of data that we visualize a lot is time series. And time series, they have trend, they have variability, and then there's the rate of change, there's cycles. When you do time series analysis, and you've probably analyzed all these aspects. So for time series, one can use all the various different types of charts depending on what you're trying to do. I'll show you one example called cycle plots. And cycle plots let you examine trends as well as cycles. So what I'm showing here is on the x-axis is the days of the week, the y is the item of interest, and so the bar, the horizontal bar shows the value on that day of the week. So you can quickly see that Thursday is the day with the highest sales. But then for each day, like Thursday, there's a sort of a gray bar line. What that is showing is the range of the data for the entire time period. Say I have data for 1 year, then I'm going to have the 52 Thursdays, and so that is showing the range for the entire year. So in this way, you can show multiple aspects of the data on a single plot. Stream graphs, I'll show you better examples of this later in the talk, but there's something newer. It's a kind of a bar graph, but with the scale, it's around the x-axis, but it's not symmetric, and you try to smooth out the data, and you're also showing the cumulative value. So it's And the colors show also the quantity, so you're not using also the depth of the bar as well as the color to show the quantity. Some things you have to be careful about here is it should be easily readable, and so there's certain things that lend themselves to stream graphs. You can show time series for many variables, and it's a lot of data. You can convey a lot of data in a short space, and it's more of something that's almost like an infographic. It's more something that engages more people as opposed to a technical graph. So you can make it aesthetic, but you do have to worry about reading the legibility of the data. Lastly, a little bit about dashboards. That's a very common business visualization where you want to display different kinds of information on one sheet. Typically, there'll be some KPIs for an industry, how things are going, and you can look at it all together on one sheet and then decide what needs action. So that's how typically dashboards are done. And this is an example from Tableau. A tool like Tableau is pretty good for dashboards. It's a lot harder to do in something like R. So here are some common tools. I mostly use R and sometimes Tableau. I'm sure you all have your own favorite tools. Any other important tools that I don't have up here that you use?
JS3.
Yes. So that's for interactive visualizations. Yes.
Shiny with R is
It's pretty good now. It's getting there. But so I agree. Yeah. Should you do visualization in Weka?
Yeah, well, you get some, I mean, one question that, you get like, power coordinates and things like that.
Okay. Good. Thanks. Yeah, and then Weka is open source
Yeah.
too, right? So that helps. Anybody else?
MATLAB or Octane?
Sure. Yeah. So the other thing is, it depends what you're doing your analysis in. So if you're doing your analysis in MATLAB, then you're going to, it's a natural for you to do some of the visualization.
Python, like the interactive photo library, the Matplotlib.
Actually, Python's becoming very popular now, and it's one of the top languages to know, read all the searches. Yeah.
What about Mathematica from Google?
Yes, Mathematica is wonderful. I don't have it. I just use their free version, the Wolfram Alpha on the web. I use it as I guess, a high-end calculator. If I ever want to do anything quickly, I just go to the website. Do you use Mathematica? Yeah. So what would you say about the visualization capabilities?
Not related was asking about that. You can interact with the images and you can note the complicated functions.
Correct. Yeah. It's very good for, I think, scientific visualization. All right, maybe you need a little help now again. The second one. Okay, so now I'm going to talk a little bit about storytelling with data. I'm not talking about journalism. You know, when you do analysis, you have to present the work, right? To your management, to your colleagues at a conference. That's all, in a way, about story. storytelling. You have to present the data in a way, actually not just the data, the results of your analysis, that you have to communicate it to other people. So that's what storytelling means here. I will use examples from many other fields because in some ways, some of the other fields, especially journalism, they are ahead of the technical fields in the communication of data. So outline, I'm going to talk about a model of storytelling. What are the genres? Talk of a couple of simple examples, and then focus on the elements of a data story. So how do you characterize story? So a story, as you all know, is an ordered sequence of steps. It's got an order. The order is important, right? And in each step, for our purposes, we could have text and images and so forth. I guess the earliest visualizations most of us saw of stories was maybe comics, you know. Well, before that, the little children's books, they have lots of pictures. But one step above that is comics, you know. It's a very good visual storytelling medium. And so now the journalism model of stories, they tell a lot of stories, right? Is they collect information, do research, interviews, they get all the facts together, and then they tie the facts together in a story, and they don't present a lot of the raw material, right? Now, what's the model for us? How does that translate? So we typically use visualization for exploration and analysis, right? A lot of exploratory analysis, data analysis, is visual, right? You create, well, the simplest thing you do is you create a scatter plot when you have some data. You don't know what to do, so you start with a scatter plot. And so you use visualization initially, but you don't spend a lot of time making that nice because it's only for yourself. Then you use visualization from presenting your results, and that's where I'm going to focus. And the tools are not necessarily the same, because when you're just doing analysis, those are one-offs. You quickly do something, you try something that, oh, all right, let me try this. And you don't worry about making the axes just right and so forth. But when you're presenting to others, you need to focus on those things also and have a story. So here's how this you characterize this area. There's sort of three basic models of narrative visualization. If you want to read more about this, there's a good paper by Edward Siegel and Jeffrey Keir. In fact, if you search for Edward Siegel, he also has a video of one of his talks, and it's very nice. I got some information from there. So so you have, in the framework, you have the visual structure, that's the genre. You have the interactive aspect, how interactive is the story, and the message. What's the message that you want to convey? And often that's text, or if it's if the author is present, like I'm here, I'm talking, I may not have that much text on my slides, right? And the approaches, so the two extreme approaches are author-driven and reader-driven. So what would be like an author-driven approach? Like, say you're presenting, even if you're presenting a paper at KDD on Monday, well, what's your approach when you're going to present? You start high level, right? You say, here's the big problem, here's what I'm going to focus on, and then here's what I tried, and these are my results. And then again, at the end, maybe summarize, so go high level. So you start high level and then go deep in. And you are presenting, there's not much interaction, so you're going to, it's all very, the steps are laid out, and it's well defined. On the other side is reader-driven, and a lot of journalism is like that. Say you're going to read some story, a data-driven story on the New York Times, that's reader-driven. The person who wrote it, they're not there to tell it to you. And so there's a lot of interaction. And that's pretty hard because now they have to figure out a way, if it's interactive, how are they going to guide you through there? If there's less interaction, then there's some clear defined steps. But if there's more interaction, so most things we do are probably some mix of this. So the first approach, the author-driven approach, is called a martini glass structure. It starts out very specific, and then it sort of spans out. And then the reader-driven approach is the drill down. So here's, to summarize, author-driven, strong order, heavy messaging. At every step, it's saying, kind of telling you what the message is, not much interaction. The reader-driven is less order and light messaging. All right, before I go into the more sort of complex and interesting examples, let me just give a simple story example, which you could probably use in presentations. So here's a simple example. What is this plot telling you?
How much investment was made by each field?
Yeah. And then you have to read, right? You have to spend a little time on it. So we could make the reader's job a little easier. I mean, are you getting some message from here other than different industry, different areas? Investment was made in different areas. That's the only message you're getting, right? But let's see if we could change some things. What do you, if you were going to make this better, what would you change?
I would like to know who's doing the investing.
Okay. Well, now we have to work with the data that's there. There's no new data, okay? You just have this data.
Well, I would love the more science, like whatever that big party is, like these people are spending X% more than everyone else.
Okay.
Like I would add a point to that form.
All right. Yeah?
You should sort it by the values.
Sorry.
So
Yes.
that you have the largest one first.
Exactly. Yeah.
You might want to know who's spending the most and who's spending the least, and maybe if it's different colors also, it might help.
Sure. Yeah. So that's sort. You're also kind of saying sort. Okay. So here's what's done here. So sort. The other thing, it's usually easier on the eyes to look at horizontal bar graphs than vertical. So that's, if that works, you should use that. So we did the sort. We put the titles sort of on the side. They're easier to read. You don't have to bend your head. Then we kind of gave a message. We said, that we invest in 4 areas. Those were the top 4. Put those in a different color, as was suggested. And then the bottom 3 are in a different color. And then there's kind of a message that 4 areas are receiving more than 600K. So now you read the line, the storyline. So there's a message, there's a story, and it's all something very simple, all done in Excel. I attended a little short afternoon storytelling thing by Carol Nussbaum. Actually, on the previous slide, I have, if you just go to storytellingwithdata.com, she has a good blog, and she often shows nice examples like this, and she'll show you simple things you can do in Excel, even if you don't want to get very fancy. And it's a good blog to read. Okay, now, I mentioned that it's not good to use chart junk. This is from a print publication. Somebody paid for it, obviously. So, I mean, as scientists, we would never do anything like that, right? I wouldn't, but you know, they've done research on this, and there's better recall in the long term about the message, the trends, if there's some junk, because people associate, they remember. So if your purpose is to create this lasting impression, then I guess it's okay to use some junk, but still try to be tasteful about it. So, I just wanted to show this example, but I typically don't make visuals like that. All right, now I'm going to focus on the elements of the data story. How do you build it up? So there's two aspects. One is the narrative part, telling the story, like on the x-axis. The y is the depth. As you add more detail, you have more depth. The simplest place we start is simple charts, like we saw in the previous example, the bar charts. So you tell some story, you have some depth, but you only had one variable, that was fine. Okay? But most of the time, we want to tell more complicated things. So on the narrative side, telling the story, you can add infographics, right? Infographics are kind of a static thing. You've often seen those big posters, and they convey a specific message about a particular domain, and they tell a story, but it's totally author-driven, usually static. On the other side, you can add what's called information sent, and I got this term from Robert Kosara. He's one of the founders of Tableau. He has papers and very good talks on storytelling with data. And again, I would encourage you to look at his website. There's a lot of useful information there. And that's where you're adding story depth, and you're doing where you're doing more sophisticated visualizations. And then if you move more on the x-axis, that's the author-driven, like we talked about, while if you're adding more depth and the information sent, then that's more audience-driven. And ideally, you want to be in this top quadrant where you have visual data stories, where you maximize both aspects. So again, in the building narrative example, again, I'm going to go to a very old example. Who's familiar with this visual? So quite a few people, right? What does somebody want to describe what this does?
It basically it charts during the war. It charts their journey from the origin city of Napoleon's army over to
Russia. Yes.
What's the temperature? The weather or the temperature?
The temperature, yes. So this is a classic. Recall, this was done in the 1800s by hand. It's showing 5 or 6 variables on one graph visually. So what this is showing, the progression of Napoleon's army towards Russia. So they take some liberties with the axes and so forth. So the brownish line on the screen is more like pink. Well, the top one is the size of the army, the bar chart, and then they're moving east as they are traveling. You see that the size is getting smaller because as it got colder or due to other, they were fighting, the army size got smaller. Often when they would cross a river, they show rivers here too. They would cross a river, they would lose people because they probably had to swim, didn't have bridges. And then along at the bottom, they show the temperature. And you see, and then the brown line is the return. And when it got cold, they lost a lot of people also. So here's one plot that's showing, it's telling the story of the soldiers. So it's a very effective visualization. However, you do have to spend time on it to understand what it's saying. So what do you think? What are your views on it? Do you think it's a good vision? Go ahead.
You could use that as a summary, maybe just after you explain all the components, divide it to subgraphs, and then at the end, just so the reader that already understands everything else, they can easily go back if they wanted to paint the bigger pictures. But I would use that as a primary graph.
You're almost saying it needs to be even more annotated. It is annotated to some extent, but like a little summary inside.
And it's overwhelming if you look at it.
That's a good point. Yeah, so what I like is showing the lots of variables on one plot. But I have seen it many, many times. So, okay. So here's a more recent example that people can relate to. This is a connected scatter plot. This is also building narrative. And it's talking about, this is an example from the New York Times. Let me see if I can actually go to the site. And it's talking about driving safe. The trouble with this visual, maybe I'll just go back to my slide. It's a very long visual on the website, and I won't be able to show it. So what is this showing? So typically, before this was done, I mean, it was common, and still is common, to talk about highway deaths per thousands of miles driven. But here what they did is they took miles driven per capita on the x-axis, and on the y-axis they have the deaths per miles driven. So they're plotting these two variables against each other, and then they're relating them to events, things, technology that's happening, that's impacting these statistics. So, and it's, so they start out in 1950. At that time, the cars were getting more powerful. There were no seat belts. The highway system was being built, so the speeds were getting higher. So the deaths were increasing. They're going up. Okay? And then over time, in this time frame, in the 60s, Ralph Nader published his book about the auto industry. Seatbelts became mandatory, and then you see that the deaths are going down. Then there was the energy crisis. People were driving less, so you see that part. That's why you see this thing going, the scatter plot kind of going around, the line crossing over. For a while, people were driving less. Typically, people are driving more every year, but at that time, people were driving less. There was an energy crisis, and the speed limit was reduced, so the fatalities dropped. And then now there's more technology, airbags and so forth, and you see this number going down. If you actually go to this site, you'll see, I mean, this plot goes way down. So it's a nice plot, and if you mouse over any piece, it'll give you more information. So it's a good visual, it builds a story, kind of takes a slightly different approach. All right. Here's another plot, again, from the New York Times, and they're talking about adding depth. So what is this plot about? They're trying to show why women's paychecks are smaller than men's paychecks. So what they do is, so they're adding depth. they first you can look at for all professions, all age groups. Okay. So this black line, so this is the wages, women's median weekly wages, and can I just go to, yeah, and then the x-axis is the men's median weekly earnings. This dark black line is the 45-degree line if they were equal, right? So that sets the baseline for you. After that, they have women earning 10% less than men. This is the first line. The second one is 20%. So now the colors are the different professions, like this brownish color is entertainment, green is science. So you can explore this chart in different ways, right? Also, they have an inset, this overall wage gap over the years. So going from 1980 to 2008, they're showing this, the women's salaries, median salary, and the men's. So you can see the overall quick summary trend. There's an inset that gives you the quick message. And then here, so let's say you're interested in the 30% line. You know, where's the biggest difference? And so along here, if you go and you just mouse over a particular dot, here it's saying marketing and sales managers, women make 31% less than men. So there's a lot of depth here. It starts high level and then you have depth. So I think this is a nice example. Can I go back? Yeah?
Show us which points that were above the 45% line.
Oh, all right. There's two. Oh, right here. This one. Let's see. You want to catch the outliers. Special ed teachers. Women make 3% more than men.
And the other one right next to it?
Postal service clerks. Women make more. They must work more efficiently. They do anyways, but.
What's interesting is also there's no significant outliers, right? Like on the downside is 30%, 40% more, but not on the
Top side.
right.
Yeah. So I think it's a nice visual. You know, some people, now you might ask, why am I showing you all these newspaper examples and not showing you stuff from science and so forth? The thing is, I think in the journalism industry, they are ahead of showing good visualizations because that's their job. And now they work with data a lot. So the examples are very applicable to what we do. They have very sophisticated people doing visualizations for them. The founder, the creator of D3 works for the New York Times now. So they do make very good graphics. So it's a good example to use. Okay, I think I can go back. All right. Here's another example of adding depth. It's about housing's rise and fall in 20 cities, the prices. Again, this plot shows you the sort of the median of the trend in prices, and then if you mouse over any of the lines, you can see particular cities, and you can move this axis on the chart. I think, how am I doing on time?
Maybe 50 minutes, 10, 15 minutes.
Okay, yeah. So I won't go to this particular chart. I'll just show you the message. So if you go to here, you can also move the time. So, like, say you can see your own situation. If you live in a big city, it's going to be represented on one of these lines. And say you bought your house in 2004, you can go to that line. You can move this and then you can see what your house would be worth today. So again, there's a lot of depth here in terms of detail and interaction. I like this other part. This is about the jobless rate for people like you. So they talk about the jobless rate. You know, we all hear of averages. When this was done, it said, you know, for the last 12 months, the unemployment rate was 8.6%. But that doesn't tell you the whole story. There's a lot of detail. So again, thank you. Okay, so here you've got the median, the time scales, January 2007 through September 2009. And this is so here's the median. Now we have for everybody, if you click on something, this says Hispanic men and women, age 45 and older without a high school degree. So there are all these lines. You can also just go to that group, like you just want to look at men. Yeah, so you still always see the overall value, the overall average, but now you can also see specific groups. And, you know, this should work. It's not working. Like, I wanted to see only men. Let's see if I can go to that. Only women. Okay, the part that's not showing up is the just the men and just the women for some reason, but you can get the different age groups, and you could get like education. So here you could see with education and age. So one thing is not working like it used to work, because now there are these different lines, but when I'm clicking, I'm not seeing that group. So, but maybe something's not working right now. Yeah?
Can you say something about what kinds of tools are used to create a visualization like that?
Probably this is done with D3.
D3?
Yes, it's a JavaScript-based language. It's used quite widely now for these kinds of graphics. You could do it in R, but it would be quite cumbersome. It's more a D3 kind of thing. Can I go back? This kind of a cool visual. This is a kind of stream graph example. So this is how a graphic on how people spend their day, and how different groups spend their day. So on the x-axis is just the hours of the day, and then this is the overall graphic. It's everyone, and it shows, you know, what different people are doing at different times of the day, which is kind of, here it's as you would expect, you know, during the work day, most people are working. In the evening, more people are watching TV and so forth. Then, after you see this overall view, you can see then what different people do. This is for everyone. And then but if you wanted to look for people who are, let's see, what would be, maybe this represents the population in this room. Maybe. So what do people do? You know, there's, so you see this different things people are doing, and then if you mouse over, you can actually see the exact numbers. At 12:20 p.m., 12% of people are doing household activities, and 29% of people are working, and many of them are at lunch, right? Are eating, or so eating. Yeah. So I don't know if this varies by, you know, if you have advanced degrees, maybe you watch less TV or something, so you can compare things. So this is a nice screen graph. It's very readable. It's a much nicer one than I showed in the other example in the first part of the talk. Okay. You know, I just saw this 2 days ago in the New York Times, this graphic about how people move between states. It's very nice. It's a very long graphic. It's interactive. By state, it shows how people moved around. So if you're interested, you could go check it out. It's not something that's easy to show, but it's a nice visual. Okay, switching gears a little bit, there's this tool, it's a special purpose tool available at this website, and they look at different countries, and they have indicators of like GNP, GDP, also population movement, and what you can plot is, so you can choose the countries, and then say you're looking at GDP or GNP or something. So you can plot the GDP in terms of the imports and exports going from one country to another. So the width of these arcs tells you the amount, and then these bars tell you the total amounts for that country, like the United States, China. So this is a nice tool. You can check this out, but it's a special purpose tool. If you're interested in this topic, you're interested in this information, you can. But the idea is also to show you another type of visualization. You can create these kinds of visualizations, these flow graphs, and D3 is very good at doing this also. All right, and I'm just going to summarize now. So I think as data scientists, you know, you do two things, right? You do discovery of, you work with your data, you analyze it, so you discover patterns, you make predictions, and then you have to do presentation. So there's a little bit difference in these two, and it's important to know. So in discovery, you explore, you build different views, you test your hypotheses, you work with lots of data. When you're presenting, you have to decide, you have to tell a story, you have to decide how much information to provide in your presentation, and that depends on whether there's a presenter or you're just handing out a paper or a document. So for presentation, because this storytelling is about presentation, is focus. A real common mistake in presentation is to have too much data. And this it happens to me all the time. I've done all this great analysis. I spent 3 months on it. I want to show the reader everything, but they don't need to see everything. They need to see the results, what my hypotheses were, what my messages, what did I find out. So it's really important to present only what's relevant for the story, just a minimum amount of information. That's something to keep in mind. And lastly, just some, so we talked about the structure, the messaging, and the interaction. Now, nowadays you do see a lot of interactive graphics, but not everybody's going to be doing interactive graphics all the time. I mean, it's a lot of work. and it's not always required. So I think it's more important to focus on the structure and the messaging. And so, you know, you want to understand the audience, what you want them to take away, choose the right display type in terms of the charts to use. Don't have clutter, we talked about that. Draw attention where you want to, use colors for that. Usually if you have large areas, it's not good to use bright colors because they dominate. So use more subtle colors. But if you have small areas, it's okay to use bright colors. And linear is better for storytelling. Guide the readers through the story. One thing, if you do interactive, always have like a way for the reader to get back to home. You know, like to the base. And then you navigate out of there again. So you don't feel lost. You know, always know that there should be some way for them to have whatever the concept of home is, right? And the other thing, nowadays we see a lot of cool graphics. So cool and readability may be at odds, so you need to do some trade-offs. Yes, it's nice to see a lot of cool graphics, but as a scientist, as an engineer, you say, well, so what? So in our work, we have to make a balance between the two. You can't just make it be cool. It's nice to make it aesthetically pleasing, but it should convey the messages. It's good to use text, use more annotations. As somebody mentioned in Minard's graph, it would be nice if there was a little summary so they knew what was happening. Start with something that's interesting. Put numbers and facts in context. It's nice you can connect the text and the graphics. You know, refer. Look at this part of the figure. Look at this figure. That's important. If you want people to focus on certain digits or numbers, label them or put them in a different color. And for the interaction, make it intuitive. The reader shouldn't have to guess. Okay. So that's, I'm just going to end with this little kind of visual that's kind of funny, but it's based on real science. So I'll stop a little bit so that you kind of read what's there. See his eyes moving around. %. That's a pretty big number. So that's why they call it suicide. Okay, I thought that was a nice graphic, but I couldn't believe it when I read it, and I said, but it's published in the New York Times, so it must be correct. And then I searched, and it's based on, some people did research, and you can see all the details there. All right, thank you very much.
So we have questions that have been submitted. Maybe we can take a couple. Okay, so I guess whoever submitted the question can ask. So I can take the first one there. So when you present to engineers or scientists, you often have different focus than for management or for business. Is there anything in terms of data visualization that you should or shouldn't do or emphasize or not emphasize for one versus the other?
So I'll talk from personal experience. If you're talking to management, they want to know what's the message. So what? You did this analysis, you tested this hypothesis. Well, so what? What can we do now? What changes can we make? So you need to have, first of all, the clear message, what your data is saying, and then what possible actions does it imply. So you need to be very clear about that. Then you can have a lot of your analysis as backup, and you show it if there's interest. If somebody asks a question, well, how about this? You know, there might be some management person who's very interested in details, and then you should be ready to pick that up. As opposed to if you're say talking to your peers, then you want to show, you know, the complexity of something you did, what algorithms you used, what you found, what was different, what's your contribution, those kinds of things. I think there it makes sense to present some of the details because you can also get good feedback. So, that answer your question?
I would take a little bit of issue with that, in that I think that engineers want to hear a story as well. They want to know why you did this as well. But you need to give them the point of it. Now, if they're your peers, they already know that part of the story, you can skip it. But I think if you're starting from scratch, I would always tell the story, always tell why I did something.
I totally agree with you, and I didn't mean to imply that don't do that part. I was saying with the engineers, do the extra part. But
Yeah.
yes, very good point. Thanks for, you know,
But
making that clear.
It could make you drill in. The managers probably won't. The engineers probably will. But it's the same content. I would
Correct,
say.
yes, absolutely. The managers are in a hurry to now go take the action.
Denise?
I'm back here.
Oh, okay. I'll take the next one.
I think my voted question is now void because she went through it. I put it up there before she presented her preferred packages.
Oh, okay. Okay.
So I will skip myself.
Are there any other questions that haven't been? Yeah, good.
So I was just asking if you think that because that evolve and we have so many tools, has changed the way we look at data, or it's still like from class, or that it's still. So do you think that will change the way we look at data, or it's still the same thing?
You know, in some ways, it's still the same thing. We look at more data now. We can do things more quickly. But time and time, whenever I read stuff, some of the basic principles that were put out by Bill Cleveland, that classic book, which I have when I joined the company I got, it's still like a Bible for data visualization. Those principles, they haven't gone away. You still need to make good basic graphs. Then you can build your story around it, you can build interaction, but your basic graph still has to be good. If you look up William Cleveland, he's now at Indiana University. I'm pretty much a lot. And he put his website, with a lot of good stuff. He works in big data analytics.
Do you think that the infographic culture is moving faster than the statistical rigor can keep up with it? So, like, are people presenting correct results in a good way? Or, you know, because we're telling stories here, and people like the story, not necessarily the rigor of how sort of interaction.
I don't necessarily think that because we're telling stories, we're distorting data. But your question was very broad about the part about are people now distorting data and all that. I can't really address that. I'm sure there are some people who do it. I have many examples of bad graphics where people are trying to distort, and I didn't, in the interest of time, I didn't show. So it varies. I mean, I don't have a standard answer for that.
I guess, I mean, not necessarily distorting, but not understanding the full story. Like presenting part of the story, but not having the statistical rigor to actually.
Oh, I
know
see.
the whole story.
And you're saying because now the graphic tools are available, more people are creating the visuals, but maybe they don't understand the sort of the underlying relationships.
Okay.
Yeah, that could be people. The one thing I see now a lot, because when people work with big data, they often do this cause effect. Two things are correlated. They'll say, oh, maybe this is causing this. I do see more examples of that now, so that can be a problem.
Okay, let's thank our speaker. Okay, so as we're a little bit behind, I think what we're going to do is shift the schedule a little bit.